I am Dr. P.N. Lakshmi Shanmugam, Assistant Professor, Department of Educational Psychology, Tamil Nadu Teachers Education University, Chennai. Let us see about the topic sampling. After completing this module, the prospective teachers are able to know the meaning of sampling, differentiate sampling technique in research, develop the skill of calculating the sample size, develop the attitude to select the appropriate sample. This is an example. Sampling is the process of selecting a few from a bigger group to become the basis for estimating or predicting a fact, situation, or outcome regarding the bigger group. A sample is a subgroup of the population you are interested in. Sampling terminology. Population or study population, the class, city, electorates from which you select a few students, families, electors to sample. Sample, the small group of students, families, or electors from whom you obtain the information to make an estimate of the average age, average income, or election outcome. Sample size, the number of students, families, or electors from whom you obtain the required information. Sampling design or strategy, the way we selected the students, families, or electors. Sampling unit or element, each student, family, or elector that becomes the basis of election of the sample. Sampling frame, a list identifying each student, family, or elector. Sample statistics, your findings on the basis of the information obtained from the respondents' sample. Population parameters are mean, the population characteristics you want to investigate, which are the average age of the class, the average income of the families living in the city, and the expected outcome of the election. Principles of sampling. The greater the sample size, the more accurate will be the estimate of the true population mean. The greater the difference in the variable under study in a population for a given sample size, the greater will be the difference between the sample statistics and true population mean. Factors affecting the inferences drawn from a sample. The size of the sample findings based upon the larger samples have more certainty than those based on smaller ones. The extent of variation in the sampling population. The greater the variation in the study population with respect to the characteristic under study for a given sample size, the greater will be the uncertainty. If a population is homogeneous with respect to the characteristics under study, a small sample can be provided a reasonably good estimate. But if it is heterogeneous, to obtain the same level of accuracy, you need to select a large sample. Aim in selecting a sample, achieve maximum precision in your estimates within a given sample size. Avoid bias in the selection of your sample. Sampling is done by a non-random method if the selection is consciously or unconsciously influenced by human choice. The sample frame, list, index, or other population records which serves as the basis of selection does not cover the sampling population accurately and completely, and a section of a sampling population is impossible to find or refuses to cooperate. Types of sampling: random probability sampling designs, non-random, non-probability sampling designs, and mixed sampling designs. Random probability sampling design. For a sampling design to be called a random or probability sample, each element in the population must have an equal and independent chance of selection in the sample. Equal implies that the probability of a selection of each element in the population is the same. That is, the choice of each element in the sample is not influenced by the other considerations such as personal preference. The concept of independence means that the choice of one element in the sampling, the selection of or rejection of one element does not affect the inclusion or exclusion of another. Example. Methods of drawing a random sample. The fish bold draw. If your total population is small, an easy procedure is to number each element using separate slips of paper for each element. Put all the slips into a box and then pick them out one by one without looking until the number of slips selected equals the same size you decided upon. This method is used in some lotteries. Computer programs a table of random numbers. This is an example. Different systems of drawing a random sample, sampling without replacement and sampling with replacement. This is an example. Specific random probability sampling design. 3 types. Simple random sampling. Simple random sampling, the most commonly used method of selecting a probability sample in line with the definition of randomization, whereby each element in the population is given an equal and independent chance of selection. A simple random sample is selected by the following procedure. Stratified random sampling is discussed. The accuracy of your estimate largely depends on the extent of variability or heterogeneity of the study population with respect to the characteristics that have a strong correlation with what you are trying to ascertain. In stratified random sampling, the researcher attempts to stratify population in such a way that the population within a stratum is homogeneous with respect to the characteristics chosen as the basis of stratification are clearly identifiable in the study population. Using the sampling proportionate and disproportionate stratified sampling. With the proportionate stratified sampling, the number of elements from each stratum in relation to its proportion in the total population is selected. Whereas in disproportionate stratified sampling, consideration is not given to the size of the stratum. These are the steps for stratified random sampling. Types of stratified random sampling. Proportionate stratified random sampling, taking proportionate samples from the population irrespective of inequality in number. Disproportionate stratified sampling, you take samples that are not proportionate. These are the example. Cluster sampling. Simple random and stratified sampling techniques are based on a researcher's ability to identify each element in a population. It is easy to do this if the total sampling population is small, but if the population is large, as in the case of a city, state or country, it becomes difficult and expensive to identify each sampling unit. In such cases, the use of cluster sampling is more appropriate. Cluster sampling is based on the ability of the researcher to divide the sampling population into groups called cluster and then to select elements within each cluster using the simple random sampling technique. This is an example. Non-random probability sampling. Non-probability sampling designs do not follow the theory of probability in the choice of elements from the sampling population. Non-probability sampling designs are used when the number of elements in a population is either unknown or cannot be individually identified. In such situations, the selection of element is dependent upon other considerations. There are 4 types. Quota sampling, accidental sampling, judgmental sampling, snowball sampling. The main consideration directing quota sampling is the researcher's ease of access to the sample population. In addition to convenience, she or he is guided by some visible characteristic such as gender or race of the study population that is of interest to him. The sample is selected from a location convenient to a researcher, and whenever a person with this visible relevant characteristic is seen, that person is asked to participate in the study. The process continues until the researcher has been able to contact the required number of respondents. Example: accidental sampling. Accidental sampling is also based upon convenience in accessing the sampling population, whereas quota sampling attempts to include people possessing an obvious visible characteristics. Accidental sampling makes no such attempt. This method of sampling is common among market research and newspaper reports. It has more or less the same advantages and disadvantages as quota sampling. Purposive sampling. The primary consideration in purposive sampling is the judgment of the researcher as to who can provide the best information to achieve the objectives of the study. The researcher only goes to those people who, in his opinion, are likely to have the required information and be willing to share it. This type of sampling is extremely useful when you want to construct a historical reality, describe a phenomenon, or develop something about which only a little is known. Snowball sampling is the process of selecting a sample using networks. To start with, a few individuals in a group or organization are selected and the required information is collected from them. They are then asked to identify other people in the group or organization, and the people selected by them become a part of the sample. Information is collected from them, and then these people are asked to identify other members of the group, and in turn those identified become the basis of further data collection. The process is continued until the required number or a saturation point has been reached in terms of the information being sought. Mixed sampling design. Systematic sampling design. Systematic sampling has been classified under the mixed sampling category because it has the characteristic of both random and non-random sampling design. In systematic sampling, the sampling frame is first divided into a number of segments called intervals. From the first interval, using a SRS technique, one element is selected. Example: these are the steps. Dear learners, try to attend this assessment. Sample is regarded as a subset of dash. The difference between a statistic and a parameter is called, which is the probability sampling method, which is the non-probability sampling method. Dash sampling is the process of selecting, increasing the sample size has the following effect upon the sampling error. Among these, which sampling is based on equal probability? Purposive sampling is also known as dash. The distribution that is formed by all possible values of a statistics is known as. Which among the following is the benefits of using simple random sampling?